This video shows the process and steps on how I find the answer for my big project. It is a report that includes complete responses to items which are asked. This report consists of a comparison of volume and pressure for a syringe within their relationship to Boyle's law. Contributing to the project, many steps are to be done, in which first of all is the research. To carry on with observing the relationship between volume and pressure on the syringe, Boyle's law is the main concept of this phenomenon. From what I researched, a common use of this law is for predicting how pressure will change when the volume either increases or decreases. Another method which helped me solve and figure out the answer for the big project is the scatter plot. It is drawn out from the data above, which shows the relationship between volume and pressure with the slope of each points within one another. The function adds on to what we know within the scatter plot points, with the line connecting to each point, which help to show the slope and on how each variable of the function affects the relationship between the volume and the pressure at each point. When it comes to graphing, technology is very beneficial. In this project, the software GeoGebra is used to create a scatter plot with the data that is given, helping analyzing the relationship of the data in very sufficient and more accurate than doing everything by hand. As a result, as the volume continues to decrease, the pressure increases continuously based on how the x-axis of the graph increase, while the y-axis of the points decrease steadily. From Boyle's law, the equation for ideal gas is PV equals nRT, which P is the pressure and V is the volume, N is the number of moles, and T is the temperature, and R is the gas constant. This makes P inversely proportional to V, pressure inversely proportional to volume. Whereas pulling back on the plunger increases the volume inside the syringe, which decreases the pressure, which then corrects when the air is drawn to the syringe, causing the volume to shrink again. Thus, in terms of algebra, the graph expresses the relationship between the two variables written as y equals 25.1438x to the power of negative 0.974, which is the form of an exponential function. After the experiment was done, the outcomes of the research, both the graph contributed by the help of GeoGebra. It shows that the two variables, pressure and volume, are inversely proportional. In terms of science, the pressure exerted by a given mass of an ideal gas is inversely proportional to volume it occupies of the temperature and the amount of gas unchanged within a closed system. Furthermore, what we know is temperature is what makes the two variables inversely related to one another. Based on what we've learned in math this quarter, equations are written out, which enables the contrast of the relationship between volume and pressure according to the syringe in the experiment to be seen. In FIF 4, interpreting key features of graphs and tables in terms of quantities and graphs showing key features given a verbal description of the relationship is greatly contributed throughout the whole research. Thus, in FIF 5, linking up the function is required, where volume is x and pressure is y. The positive integers would be an appropriate domain for the function. Thus, FIF 6, the scatter plot interpreted above, is written out as an algebraic expression in the form of an exponential function. Merely connected to FIF 7, determining and plotting out the function of this experiment with the help of technology is essential, which is based exponentially since it involves the increasing and decreasing variables of the function. Other than math, this research includes chemistry. This includes gas laws and being able to interpret the relationship between volume and pressure. It was figured out from this research why the two variables of the ideal equation are inversely proportional to one another because temperature is what affects everything relating to the gas law. So that's all for the video. So I hope you enjoy and hopefully I get good grades this quarter. Thank you.